Alright, so in this video we'll be looking at algebraic expressions. This is my first video covering actual algebra and not just reviewing pre-algebra, so let's get started. Now in the first video in my series I showed you guys this definition from Merriam-Webster, and I'll show it to you guys again. So algebra is a generalization of arithmetic in which letters representing numbers are combined according to the rules of arithmetic. And what I focused on in the first video and what I'll look at again is generalization of arithmetic and letters representing numbers, which we know as variables. I won't dwell too much on this definition here, but I want you guys to keep it in mind as we talk about expressions. So what is an expression? Well, an expression is just something that we can use to represent a real world value. A better definition might look something like this. An expression is a mathematical statement that combines numbers and/or variables using mathematical operators to represent a value. So with expressions, we take numbers and we can also use variables, and we combine them together with plus and minus signs to represent a value. Now you guys already know expressions. You've been working with them throughout most of your math career. An example of an expression might be 5 plus 4 times 3. Now this is an expression here because they have numbers and it can represent a value. So I'm going to set up a hypothetical situation here to show what this expression might represent. So let's say you want to calculate how much money you have saved over a given period of time. So in this case, if we want to go along with that, we'd say we start with $5 and each week we get $4 and we save for 3 weeks. So we start with $5 and each week we get $4 for a period of 3 weeks. So that expression will tell you how much money you have saved. Now that's an expression, but if we want to make it an algebraic expression, we have to use variables. So, and of course a variable is just a letter that we use to represent a number that is changing or varying. So with this expression here we have three numbers, all of which can be represented as variables. So let's do that now. So this 5 we said was the amount of money we start with, and we can use the variable x for that, and 4 is the amount of money we get per week, and we can use the variable y, and this 3 is the number of weeks we have been saving, and we can use the variable z. So now we have some variables, and we can rewrite this expression using those variables. So then it become x plus y times z. So this expression right here represents how much money you have saved, and it's a general expression, meaning that anybody who is saving can use it. They just plug in how much money they start with for x, how much money they get per week for y, and the number of weeks they've been saving for z, and they can calculate how much money they've saved. But this might not be useful for you. What might be more useful is if you only had one variable and set the other numbers to be constant. So let's say you wanted to show how the amount of money you've saved changes over time, or the number of weeks you've been saving. So then you make z your variable and set the other numbers to be constant to the numbers we had up there. So then we could say 5 plus 4 times z, where z is the number of weeks you've been saving. In this case, you plug in different values for z, and you calculate different values corresponding to the amount of money you'd have after z number of weeks. So if you wanted to calculate how much money you'd have to have for 5 weeks, you just plug in 5 for z, and the expression would then become 5 plus 4 times 5. Alright, so now that we have an algebraic expression, we can discuss some terminology to make sure we're on the same page here. So an expression is made up of terms. A term is just a number or a product of a number and a variable. The terms in an expression are separated by plus or minus signs. So in this expression we have here, I'll rewrite it. 5 plus 4z, we had two terms, 5 and 4z, and you see they are separated by a plus sign. Now this expression only had two terms, but an expression can have any number of terms ranging from 1 to infinity. So talking about terms though specifically, a term can be made up of a number or a number and a variable. The number part of a term we call the coefficient, and if a term contains only a number and no variable, we call it a constant. So in this term here, it's just a 5 with a number and no variable, so we call it a constant. And in this term over here, the 4 is the coefficient, and the z is the variable. Now I've drawn a picture down here, a little diagram that'll hopefully make it a little more clear for you guys. You see that we have an expression that's made up of terms which must contain a coefficient, and they also may contain a variable as well. The terms in an expression are separated by a plus or minus sign, and there can be any number of terms in an expression. So let's go over some examples to make sure we know what we're talking about here. So our first example, 3x minus 8 plus y. We have three terms. In the first term, we have 3 as the coefficient and x as a variable. In this next term, by the way, the minus sign in this term goes with that term, as does the plus go with this term. But anyway, there's no variable in here, but there is a numerical coefficient part, negative 8. So that negative 8 we just call a constant. Now in this last term you might be puzzled a bit. If you think back to the definition, you know there has to be a number, maybe a variable. There is one in this case, a y, but there also has to be a number, and this coefficient, like many things in math, is the invisible 1. So the coefficient is just 1 and the variable is y. Next one, 5. You just see a number here, but don't be puzzled. It's just a one-term expression where the term is a constant, right? Because there's just a number but no variable, so that term is a constant. Next one is x squared y cubed times z. Of course, this is just one term, and I made this expression here to show you guys that our terms can have more than one variable. So this term has three variables, x, y, and z, and our variables can also be raised to powers. So x squared, y cubed, and z to the 1, another invisible 1 there. Of course, this whole thing is the variable part, and the numerical coefficient is 1. Now last one, x plus 5 equals 7. Right away you see an equal sign that should raise a red flag, because expressions do not have equal signs. This would be called an equation. We'll talk about these in a couple videos, but for now just know that expressions and equations are different. That's all I have for this video. In the next video we'll be looking at writing expressions ourselves, so I'll see you guys then.